Picture a stage in Austin, Texas. Rows of investors in blazers instead of the usual Tesla crowd of fans in Model 3 t-shirts. It's March 1st, 2023, and Tesla is holding something it has never held before, an investor day. Elon Musk is on stage, flanked by more than a dozen of his own engineers, most of whom the public has never heard speak before. Among them is a man named Colin Campbell, Tesla's vice president of powertrain engineering. He isn't a household name. He's about to become the center of a very different kind of story than the one usually told about Tesla reveals. Because contrary to what a lot of viral videos will tell you, there was no single dramatic night where Musk walked on stage and unveiled a new engine that sent every automaker on Earth into a 48-hour panic. What actually happened was more interesting, more documented, and honestly more important than the myth, because you can go check it yourself. Tesla's Investor Day presentation is on their own investor relations site. It's covered by Bloomberg, Reuters, Forbes, and half a dozen trade publications that were sitting in that room. So let's talk about what Tesla actually said, what it means, and why, even without the Hollywood theatrics, it's still a genuinely big deal. At that March 2023 event, Tesla's leadership team spent roughly 3.5 hours walking through what they called Master Plan Part 3. A sprawling presentation about sustainable energy, manufacturing philosophy, and Tesla's next-generation vehicle platform. Buried inside that broader pitch was a specific set of claims about a future drive unit, the combined package of electric motor, power electronics, and gearbox that actually moves the car. Campbell told investors that Tesla's next drive unit was being engineered to cost approximately $1,000 to produce. He said it would use zero rare earth elements, a shift from the permanent magnet motors Tesla and most competitors were using at the time, which typically rely on materials like neodymium and dysprosium, largely refined in China. He also said the design would require about 75% less silicon carbide, a semiconductor material used in the power electronics that's effective but expensive, and that the whole next-generation manufacturing approach, smaller factories, simplified wiring, fewer controllers, could roughly have the cost of building Tesla's future vehicles compared to the existing Model 3 and Model Y platform. That's it. That's the actual announcement. No 20,000 revolutions per minute figure was given. No 0 to 60 time was attached to this specific motor. Power, torque, and top speed for this drive unit were, by multiple contemporaneous reports, notably absent from the presentation. A detailed Wall Street analyst pointed out with some frustration afterward. And here's the part the hype videos conveniently leave out. Investors weren't thrilled. Tesla stock actually fell nearly 6% in after-hours trading following the event. And by some estimates, the company's market value dropped by roughly $40 billion in the days that followed. The complaint from analysts at firms like Citi and Morgan Stanley wasn't, "This is too advanced to believe." It was closer to the opposite, that Tesla had teased a next-generation vehicle platform for months, and then delivered a lot of engineering philosophy without a car, a timeline, or hard performance numbers to back it up. So if you're picturing panicked emergency meetings at Ford and Toyota the next morning, the honest answer is, that's not really how the days after Investor Day played out. At least not according to any credible reporting from that week. Because underneath the disappointment about missing theatrics, the substance of what Campbell described is genuinely significant, just not for the reasons a clickbait thumbnail wants you to believe. Start with the rare earth claim. Permanent magnet motors get their strength from magnets containing rare earth elements, and the global supply chain for those materials is heavily concentrated in China, which handles the overwhelming majority of rare earth processing worldwide, even when they're raw or is mined elsewhere. That concentration has made automakers nervous for years. It's a geopolitical choke point sitting inside a component every EV depends on. An automaker eliminating that dependency entirely, if executed at scale, would remove a real vulnerability, not a theoretical one. It's worth noting Tesla has moved in this direction on other vehicles since. The standard Model 3, for instance, has used a rare earth-free induction motor in some drivetrain configurations for years. So this wasn't Tesla's first attempt at reducing that dependency. The 2023 announcement was about extending that philosophy to permanent magnet designs without losing their efficiency advantage, which is the harder engineering problem. The silicon carbide reduction matters for a similar reason. Tesla was actually the first major automaker to put SiC power electronics into a mass-produced EV back in the Model 3 in 2017, a move that helped kick off a boom in the SiC industry, which analysts at the time projected could grow into a multi-billion-dollar market by the back half of this decade. SiC chips are more efficient at converting battery power into motor output than older silicon designs, but they're expensive to manufacture. Tesla's 2023 claim that a new thermal packaging approach could extract roughly twice the heat dissipation of an off-the-shelf inverter design, letting them use meaningfully less SiC per vehicle, is a cost and efficiency argument, not a raw power argument. It's a kind of unglamorous engineering that doesn't produce a viral 0 to 60 number, but does show up, eventually, in a company's gross margins. Then there's the $1,000 target itself. Reasonable people can and should be skeptical of any company's own cost projections for a product that doesn't exist yet in production form. That's just good financial literacy, not cynicism. But directionally, the claim lines up with something that's broadly true about Tesla's approach to manufacturing. They've built a track record of designing components in-house rather than buying them from suppliers, and using that vertical integration to squeeze out cost the rest of the industry often can't, because they're not paying a supplier's margin on top of their own. According to Tesla's own presentation, prior vehicle generations had roughly 20% of their control units designed internally. The next generation platform was targeting closer to 100% in-house design. Fewer external parts, fewer suppliers, fewer markups. This is where an honest script has to slow down, because, and then everything Tesla promised came true on schedule, is not what the record shows. Tesla's next-generation vehicle platform, sometimes referred to informally as Model 2 or Model Q in media coverage, though Tesla has never used either name officially, has had a bumpier path than the 2023 slide suggested. The Gigafactory Mexico plant, which was supposed to be the anchor for a lot of this next-generation manufacturing, was announced at that same Investor Day, with Musk confirming plans to build near Monterrey. Construction has faced repeated delays. As of 2026, reporting indicates the plant's timeline has slipped into the latter part of the year, years behind the initial framing. Rather than a standalone cheap car built on entirely new architecture, Tesla's actual near-term move toward affordability came through stripped-down versions of existing Model 3 and Model Y, which is a more incremental approach than Master Plan 3 implied back in 2023. Some elements of the next-generation platform's engineering philosophy did make it into production, though. The Cybertruck, for example, adopted a 48-volt electrical architecture, one of the specific technical details Campbell mentioned in the 2023 presentation, reducing wiring complexity and weight compared to the traditional 12-volt systems used throughout the auto industry for decades. And a fully driverless concept riding on next-generation platform ideas, the Cybercab, was shown publicly in October 2024, with Tesla targeting volume production starting sometime in 2026, according to the company's own investor communications. So the honest scorecard 3 years out is mixed. Some of the manufacturing philosophy is real and shipping in pieces. The dramatic $25,000 car, all-new platform vision from 2023 has been slower and messier than the stage presentation suggested. That's not a scandal. Ambitious hardware roadmaps slip constantly across the entire auto industry. But it is a very different story than the race is already over. It's true that Tesla's competitors have struggled with electric vehicle profitability, and that part doesn't require exaggeration to be a real story. Ford has publicly and repeatedly disclosed significant losses in its EV division in its own quarterly earnings reports, a fact the company itself has been unusually candid about, framing it as the cost of building out capability ahead of scale. General Motors has likewise taken years longer than initially projected to bring its Ultium-based EVs to volume profitability, and its Cruise robotaxi unit, a separate but related bet on autonomous technology, has faced its own well-documented setbacks. These are genuine structural challenges, not hype. At the same time, framing this as everyone else is doomed oversimplifies a more complicated picture. BYD, the Chinese manufacturer, has grown into one of the largest electric and hybrid vehicle producers in the world, competing aggressively on price and manufacturing scale, particularly across Asia, Latin America, and increasingly Europe. A genuine and fast-moving competitive threat that most credible industry analysts treat seriously. Traditional automakers have also made a notable strategic concession. Ford, General Motors, Rivian, and several others have adopted Tesla's charging connector, now standardized industry-wide as the North American Charging Standard, or NACS, giving their customers access to Tesla's supercharger network. That's a real, verifiable shift, and it says something meaningful about the relative maturity of Tesla's charging infrastructure compared to the fragmented, often unreliable networks other automakers and third parties had built independently. It's not proof the race is over, but it is proof Tesla built something the rest of the industry decided was easier to license than to replicate. Strip away the theatrics, and there are a few advantages that are well documented and genuinely difficult for competitors to close quickly. The first is data. Tesla's vehicles have, for years, collected driving data at a fleet scale that dwarfs most competing autonomous driving programs, simply because there are millions of Tesla vehicles already on the road running some version of driver assistance software, compared to much smaller specialized test fleets run by companies like Waymo or Cruise. More real-world miles generally means more edge cases captured, which is a genuine input advantage for training driving-related machine learning models. Though it's worth being precise that data volume alone doesn't guarantee a superior driving system. Quality, labeling, and model architecture all matter too. The second is vertical integration in manufacturing. Tesla designs its own vehicle computer chips, works closely with in-house teams on battery cell development through its 4,680 cell program, and builds large-scale factories using techniques like giant single-piece body castings that reduce the number of parts and robots needed on an assembly line. This kind of integration is expensive to build, but once built, is genuinely hard for a legacy automaker, with decades of supplier relationships and unionized plants built around a different manufacturing philosophy, to simply copy. The third is charging infrastructure, which, as mentioned, has become enough of an industry standard that competitors are now paying to use it rather than trying to outbuild it. None of this means Tesla's position is invincible or that its rivals can't close the gap over time. Ford, GM, and Volkswagen collectively still sell far more vehicles worldwide than Tesla, and legacy manufacturing scale, dealer networks, and financial resources remain real assets in a long competitive fight. Toyota, despite a slower EV pivot, remains the world's largest automaker by volume and has enormous engineering and manufacturing resources it can redirect. The idea that the entire century-old auto industry has already lost to a single company is a compelling story for a video thumbnail. It is not a conclusion supported by the range of credible financial and industry analysis available as of 2026. Tesla's 2023 Investor Day did lay out a coherent, technically serious vision for cutting the cost of an electric drive unit dramatically, cutting dependence on rare earth materials and expensive semiconductors, and building vehicles with far fewer parts and far more in-house design than the rest of the industry. Some of that vision has made it into real shipping hardware. Some of it has been delayed by years. None of it involved a single dramatic on-stage unveiling that sent competitors into emergency panic mode, and none of it, on its own, is proof that the electric vehicle race is over. What it does show is something a little less cinematic, but arguably more useful to understand. Durable competitive advantage in this industry isn't usually built in one unveiling. It's built through years of unglamorous decisions, which components to design in-house, which materials to engineer around, which manufacturing bottlenecks to attack first, compounding slowly enough that, viewed all at once years later, it can look like a single moment of disruption. It wasn't. It was a plan partially executed, still being tested against the same hard physics and harder economics every automaker on the planet is wrestling with right now. If there's a genuine lesson in Tesla's next-generation drive unit story, it's not that the race is over. It's that the companies willing to make unglamorous, expensive, long-horizon bets on manufacturing fundamentals, not just flashy specs, tend to be the ones still standing when the hype cycle moves on to the next thing.